Hey everyone. So today we'll be preparing for our interview. So recently I applied for PayPal and I got a call from them. So they have a pretty long interview. I will say I'll if I can just take a screenshot of it and show you what really is going on there. Like yeah, I'll just show you the high level requirement of what is going on. So after taking screenshot, if I go here and pictures, screenshots, yeah, this is how, this is what they are going to ask me. So there is a live coding assessment, first of all, that is with Carrot, or I don't know how to pronounce it, but yeah, it's a third party which has their own set of engineers which will be interviewing for 60 minutes. So it will be basically a lead code round. I'm not sure. I need to figure out what kind of questions they will be asking. So yeah, I need to prepare for this first. The list is so long, like there are total of 4 steps, and then once you clear this, then there will be a recruiter round. Then there will be step 3, technical assessment. I don't know what's that about. Like they have written maintainability and cleanliness. uh, that's about it. And you will have opportunity to learn about their engineering culture, which is a good thing. And the next, the final round, which is a four rounds: problem solving, then design, logic, and maintainability, coding. So I guess I guess it can go anywhere from this point. And then there is a system design logic. Oh, okay, got it. So they'll ask me to create some data structure and work practices. So yeah, yeah, okay, got it. So I'm pretty much excited for this opportunity, as well as very nervous for what's there in front of me. Um, but you know what? There were no opportunities for so long, and it's if you see if we see the calendar, I don't know how to open that. Yeah, since I guess this is the first opportunity that I've got since March, since I got laid off. I am planning to make a separate video. Like uh, I don't make really polished videos as you have seen so far. If you have been looking at my videos, so I'll be posting about my layoff that happened in the month of March. And since then, yeah, as I was saying, since then I did not have any opportunity, and this one showed up. So yeah, like I did got some opportunity, but that was for not a full time. It was for contract positions, and it's totally different ball game over there. Here, um, so yeah, let's stop wasting time more on this, and let's jump into lead code and see. So in past 6 months, in past one year, they have asked this question a lot. um, so let's sort them according to the frequency. And I have solved how many? 7, and 7 out of 15. So let's give it a shot and see what we can come up with if we are able to solve this. All the all I'm doing is I'm practicing um, the way we should talk in an interview. So this is really helping me. Usually I don't speak a lot of English, as you can see, but yeah, this speaking to you guys, speaking to like doing coding live does really forces me to communicate my thoughts in a better way. So yeah, this is what I'm doing. If and showing my learning phase, how I'm learning stuff, and so on. So I'm not a brilliant coder. I'm just a normal daily life coder, and who is just trying to get a job. Um, so yeah, I really love front end. Like that's what I like in whole software engineering. But I don't limit myself to front end, and uh, yeah. So lead code is must. So let's do this. Let's turn on the camera. Sorry, the timer, and let's go ahead. So pair of songs with total duration divisible by 60. Um, let's increase this and a bit of font size. So you are given a list of songs where each song has duration of time I. Okay, list of songs is there and duration of, okay, in seconds. Return the number of pairs of song for which their total duration in seconds is divisible by 60. Formally, we want the number of indices ij such that I is less than j, with time of I plus time of j module 60 equal to 0. So I didn't get anything of that statement, but looks like, yeah, let's see the example. And okay, so the example is 30, 20, 150, 100 and 40, right? These are the duration of the songs in seconds, right? Okay, three pair have a total duration divisible by 60. Time 0, time 2, a total duration 180, 20, 100, total duration 120. So looking at the solution, I think what we need to do is we need to compare e- uh, each each song duration with other song, and uh, a song which is uh, like index is more than the current one that we are comparing. So 30 will be compared to um, the 0th index song will be compared to the songs that are ahead of it. So yeah, we have to do it for every pair, and as and when we get the um, get the duration who on which, like when we add those two durations and mod it by 60, then it gives 0. So that's when we'll increment the count. That's what I believe this is. But like I understood this is the question, but my question is, will there be a time when there is no output at all, like output will be 0? That I mean by that is, like the question I'll be asking to interviewer is that, like will will there be always two numbers which on adding them will definitely get a 180? Okay, so that's that. And So okay, got it. Okay, so yeah, looks like the array won't be empty at any point of time. So if time of I is 1, so at that point of time, I guess we have to return 0, because there is nothing to be traversed at that point of time. So basically the brute force would be O of n square, as we'll be traversing through the array itself. So so basically we'll line out the count, which will be 0 initially. We'll be returning the count. What we'll do is, for let time is equal to, sorry, let I is equal to 0, I is less than time dot length, yeah, I plus plus, and oh sorry, and for let j is equal to 0, j is not less equal to 0, j plus 1, we have to increment the count to plus 1 and do this time dot length minus 1 I plus plus j plus plus. Sorry, yeah, this is where where things can get really wrong, doing I plus plus here. So make sure, I need to keep that in mind. So yeah, once we've got that, what we need to do is, we need to add, let's okay, let's not complicate stuff. So let sum is equal to, or directly write, if time of I plus time of j mod by 60 equal to 0, then we will return, we will update the count plus plus, or else we'll just leave as is. So I'm a bit confused about, so let's say I'll start with this guy 60, then I will check this, and now I also need to check this guy, right? I just cannot. So once I check this, yeah, I need to go till the end. So if I run this, what's the problem now? Okay, so I added these both. Am I doing something wrong, or is it like, what is going on exactly? So console.log time of I plus time of j. Okay, I'm getting all of this. So Okay, so what I'll do is I'll get this both this guy, and you know what, I'll just take this both. I don't have to write this again and again. Let sum is equal to this guy, then sum, and sum mod 60. What does it give us? Gives us, so let's see. Open raw 50 plus 50 will give us nothing. This guy, okay, yeah, 50 will, okay, 0, this guy, then this guy. So 1 2 3, three times we got zeros. Then we also did count plus plus, right? Then equals to 1. If I keep it like this, let's do this. Let's call it sum. Yeah. Okay, I guess there was some problem with that. Oh yeah, like I did not. Okay, I got it. So I did not put it in brackets. That's why it was happening like that. And I guess it would fail because O of n square into 6 into 10 raised to 4. So, okay, it took a lot of time, and this is basically equivalent to, so how can we, it is equivalent to the two sum problem. So but in two sum we were always on the lookout for for the two values which would end up equaling with the target. In this case we just want to look how we can, get to the point where can, yeah, can we do this in linear time, that is O of big O of n. So 30, okay, what can we do in this case? Like the term memory complexity is O of 1 in the first case that we solved, but how can we reduce the time complexity? O of 1 is there, sorry, 30 is there, then how can we make sure that 30 20, so 30 plus 150 is 180, right? Yeah. So what can we do in this case? Hash map, if I use hash map, then what will it be good? O of n square, O of n square. Let's say, hint, we only consider each song length modulo 60. We only need to consider each song length modulo 60. We can count the number of songs with length modulo 60 equal to r and store that in array of size 60. What do you mean? Length mod 60 equal to r and store that array. So what is 30 mod 60? Like, what will it give us? So let me check. 30 mod 60 is how much? 30, then 20 mod would be 20, 150 mod 60 is 30, then 100 mod 60 is 40, and 40 mod 60 is 40. So okay, it gave me 3, but we count the number of songs with length mod 60 equal to r and store that in an array. So 60 mod 60 is 0. Okay, let me see the editorial. I am brute force is nested one. Yeah, so that was the basic one. Use an array to store the frequencies. Let's dive deep into the condition to examine the relationship between time I, time j, assuming that a p are two elements in the input array time we have a p. What the hell? Hence, all we need would be finding the pair of element and time so they meet these conditions. So 60 so 30 plus 150, then 100, then 40, I didn't quite get it. So we have remainder in 60 mod, then remainder of 0, then else, what the hell? Yeah, 2 sum is hiding, but what the fuck is going on, guys? Pairs of songs.
Hello guys, welcome back to Take Dose, and in this video we will see pairs of songs. So let's first song has a there is time example given. So let's assume that we have 5 songs from 0 to 4. Our goal is to find the number of pairs of songs for which the total duration is divisible by 60. Now this problem seems very simple. So in this case there are basically right. So that is this 30 comma 150, 20 comma 100 and then 20 comma 40. But how do you actually find the pairs? So you need to just return the total number of pairs in such a way that adding the value of two pairs you can divide it by 60, right? So the mod value should be equals to 0. So how do you actually find the pairs? One simple approach can be to just take a pointer, like take an I pointer and take a j pointer. Now for each of these value, let's say in this case it is 30, you will iterate for all the values and check adding which value to 30 gives you mod 60 equals to 0, right? So let's say your first pair was 30 comma 20 to 0, but it is not equal. 30 plus 30 will be actually comma 150, therefore it for all the songs, for all the approach. And so let us look at some observations to do this. Let us assume that we are given two numbers, let's say this is x and y, and there is a divisor which is z. Now in our case this divisor is actually 60, right? But let's say it is z. Now how to know if adding two numbers will be divisible by z? So one simple process is to just add this number x and y, take x plus y and take mod of z, and that value should be equals to 0. Then we know that x comma y forms a valid pair. Okay. But if x plus y is divisible by divisor z,
What the hell?
then you can also say like if you take the remainder of this x and y with the z and add them together, then the value should be either z or it should be 0. So let's assume that you had a number x and you took x mod z, remainder was r1. You took y mod z was remainder r2. Now in order for x plus y to be divisible by z, your r1 plus r2 should also be divisible by z, but this remainder was calculated by taking mod of z. So this r1 should always be less than z and this r2 should always be less than z. So r1 plus r2, r1 plus r2 should always be less than 2z, right? So what is the minimum value of r1? Minimum value of r1 is 0. And similarly the minimum value of r2 is also 0. So this r1 plus r2 will range from 0 less than equals to r1 plus r2 less than 2z, right? So at what values of this r1 plus r2 can z divided? Well, if the r1 plus r2 value is either 0, then you take mod with any number, okay, and you will always get 0. So this is said as divisible. So 0 is divisible by any divisor. Otherwise, if the number here, that is r1 plus r2, is equals to z, okay, so z mod z will be equals to 0. So these are the only two values falling in this range, which is 0 and z, right? So according to our remainder observation, r1 plus r2 must be equals to z or it must be equals to 0, okay? Now in this case, let's take an example here. Let's say the z value is 60 and our x and y values are 140 and 100. So 140 mod 60 is 20 and 100 mod 60 is 40. Now in order for x and y to be divisible by 60, 20 plus 40 should be divisible by 60. So 20 plus 40 should either be 0 or it should be equals to 60. In this case, it is equals to 60. Therefore, you can say that these two numbers are divisible, right? So this is the observation using remainder. But how does this observation help us improve our time complexity? How it will help us? So let's say this is our original array for song timings for each of the songs, and this is our remainder calculated, okay? So you can do it in place using the same array if the array is mutable, which is true for this case. Now let's say we have the remainder array, which is the remainder timing. It is calculated mod of z value. Z value in our question is 60, okay? So all the values are taken mod 60. Now these are the remainders. Now in this case, the question is slightly changed. Previously, what was our goal? Our goal was to find two pairs, that is x plus y must be divisible by 60. Mod value should be 0. But what is our new question? If you take this remainder array, then if we are at a given element, let's say if we are at this 30, then let's say R1 is equals to 30, right? Now you don't know about R2, but your divisor value Z is equals to 60. So if R1 is 30, you want R2 to be either equals to minus 30 or R2 should be equals to 30, right? So that when you add R1 with R2, then the value should come out to be either 0 or it should come out to be 60, right? But the remainders calculated here are all on positive numbers and it will always be positive. As I have already said that the remainder sum will range from 0 to 2z, and if you see the range of remainders, it will always be positive starting from 0, okay? So this value is out of the question. So now you are left with only one value, which is 30. So you need to find, if we are seeing a 30, is there any other 30 to the right? Okay. So what can you do? You can just traverse through the array and find that yes, there is 130 and there could be another 30, right? There can be multiple 30s. Let's say in this case, there is 130. So you identified that our count can increase, like this is a valid pair. Okay, that's true. But isn't it taking longer time? Like you have this 30 and now you are searching for another 30. Let's not take this 30. Let's take this 20. Okay. So our R1 value is 20. Our divisor value is 60 and our R2 value is unknown. Okay. Now what can be the possible value of R2? R2 can just be D minus R1, which is nothing but 40. Okay. It has to be 40. So is there any 40 in this entire array leaving this value? Obviously. Is there any 40? So how will you make this search? How will you search for the element? You can just traverse through this array and find that there is a 40. There are multiple 40s in this case. So if you just go through the entire array, then for each element you are doing order of n operation, and therefore for all the elements you will be doing n times n operation, so that will be n square, right? So this is exactly the same time which we did using the simple approach. But how do we improve the time here? You can see that there is a data structure which is optimized for searching an element in an array, and that data structure is nothing but a map. So what you can do is you can store all these values in a map. Let's say you stored 30 with count value of 2, that is it is occurring 2 times. You stored 20 with a count value of 1, and you stored 40 with a count value of 2, right? So when you are seeing at 20, you want to find if there is a value D minus R1, that is 40, present in this entire array. You can do it on average time of O1 using this map. So yes, there is 40. And how many 40s are there will determine the number of combinations which you can form. It will depend on the number of 20s and number of 40s, right? So since we are seeing 120, here 40s are 2, therefore there can be 2 such combinations, which is 2 into 1. Number of occurrences of 20 into number of occurrences of 40, right? So this is one way of doing it, like making a fast search on map. So if we are assuming that searching on a map is order of 1 on average, let's say on worst case also order of 1, then for n elements, we will be doing it in order of n time. Okay. So let's see a quick dry run of this entire example. Let's say this is our example. This is A. Okay. And this is the remainder array. Now this is our map, which is a key value pair. So this is like mod 60. This is the remainder array. And using this remainder array, we have found the map. We have also found the frequency of all the remainder elements, right? So we need the frequency in order to count it. So how do we count it? We don't parse it on the remainder array. We will parse it on the map, because on the remainder array, the same elements can occur multiple times, but that will be taken care in the map. Okay. So when you are at this 30, then there are 2 pairs. So for 30, you need another 30, right? So this 30 2 times will be basically contributing to just a count equals to 1. That means only one pair will be available using 2 30s. Now when you are at 20, then you need 40. Okay, because the divisor value is 60. So 60 minus 20 will be 40. Is there 40 available? Yes, 40 is available and the count is 2. So the number of combinations which you can form using 20 and 40 will be equals to count of 20, which is 1, into count of 40, which is 2, which will be equals to 2, right? So you had one combination using 30, 2 combinations using 20 and 40. Okay. Now if you move on to the next value 40, then you will see that it has count 2. So for 40, you need to find value 60 minus 40, which will be 20. So 20 is already present and its count is 1. So you might add 2 into 1. Count of 40 into count of 20, which will be 2. But if you notice here, we are doing duplicate additions because we had already made combination of 20 with 40. But again, making combination of 40 with 20 is wrong. Okay, we are doing it 2 times. So this will not be included. So we need to take care of the duplicates. Okay, so this is one problem which we need to solve. What is the other problem? The second problem is that if we happen to find remainder equals to 0 or remainder equals to 30, then its pair occurs in itself. Okay. So for 0, if you are looking for a pair element, then it will always be 0, because it cannot be 60. It cannot be 0, 60, because we are taking mod of 60. So mod of 60 will range from 0 to 59, and you will never find an element equals to 60 in the remainder. So 0 will make valid pair with itself. So the count value should be greater than 1. Okay. And the same goes for 30. 30 will make pair with itself and the count value should be greater than 1 in order to make a valid pair. But how to count the number of pairs found by 0 or found by 30? So this is our second problem. So let's solve both these problems. So let's see at the first problem. So in the first problem, we were adding combinations multiple times. So let's say in the map, it was given that 10 is occurring 2 times and 50 is occurring 3 times. Then when we were at 10, and our divisor value is obviously 60, when we were at 10, we were searching for element 50. So 50 was present, it was present 3 times. So the total count value would be count of 50 into count of 10, which is 6. Okay. Now when you move to 50, when you move to this 50, then again what we were doing, we were counting what is the pair element. So for 50, the pair element will be 60 minus 50, which is 10. So again 10 is occurring here 2 times. So we will again multiply 3 with 2 and add 6 to it. So the count value will be 12, but this is wrong. We are doing duplicate times. If you see on this number line, then all our remainders will range from 0 to 59. Okay, which are covering 60 elements. So for any given element, there will always be a pair element as a mirror, mirrored at value 30, right? If you take from 0 to 60, then it will always be mirrored at this value 30. So for 10, the mirror value will be 50, right? So what we can do is we can count only from 0 to 30. We don't need to count this part, because even though there are values in this part, let's say this was something 40 and this was 45. So in order for this to exist, there should be another corresponding pair on this side, which should be 20, right? So when we count from 0 to 30, then this 20 will take care of this 40. So we don't need to do calculation on this part, right? So this is one important observation to make. But we need to leave out this 0 and 30 because they are special cases. So we will run from 1 to 29. So our first problem is solved, which was counting duplicates. Now let us see for the second problem, which was special case of counting the number of pairs with 0 and 30. So in this special case, when our remainder is equals to 30 or 0, then count of valid pairs will always be n minus 1 into n by 2, where n is the count of number of remainders of 30 or 0. So let's take an example. If the count of remainder 30 is 4, then the number of pairs will be n into n minus 1 by 2. So that will be 4 into 3 by 2, which will be 6. Okay, it will make 6 valid pairs, and I have drawn the diagram. Like you can take this first one and it can make 3 different pairs. For the second one, it can make 2 unique pairs, and for this third one, it can make only 1 unique pair, right? So if you add them together, it will be 3 plus 2 plus 1, which will come out to be 6. So this is how it pairs, including the special cases as well of this entire solution. So in this optimized version, it will make use of all the other examples which I have shown and all the observations which I already shown. Now, okay, counting 60. So if you all these array indices will range from 0 to 59, but I have taken divisor equals to 60 just to dry run this example. Okay. Now we will pass through this array once. So this is like 3. This is 3. Okay. So the count of 3 will be increased. So this will be equals to like 1. We go to 4. 4 mod 6 will be 4. Increment the count. Go to 0. Increment the count here. Go to 2. Increment the count here. Go to 4. Increment the count here. It will be 2, right? So all the frequencies have now been counted. So what will be the count of number of pairs in this case? Now we will just pass through this entire frequency array and find the count. For 0, it will be n minus 1 into n by 2, right? So the count is 1. Okay. So only if the count is greater than 1, it can form a pair with itself, because since it is having just a single element, it cannot do that. For this one, it is 0. Now for this 2, the value of frequency is 1. So what is the corresponding mirror image of this 2? So it will be 6 minus 2, which will be equals to 4, right? So the count of 4 is already 2. So we will just multiply 1 with 2, and the count value will be incremented from 0, and it will now become 2. And where should we stop? We will obviously stop before n by 2. So we will stop at 2 just to avoid duplicate calculations and calculate the special cases 0 and 3. If you look at 3, then it should have count greater than 1 in order to make a valid pair with itself, right? So both these 0
Okay, so if t of I mod 60 equal to 0, we simply calculate count plus else we need to check how far is t of I is far from next multiple. So example 100 is 20 far from 120, which is a multiple of 60. Achieve this, we do steps time of I to 60 equal to 0. This means rem should come between 159. Now we check how far is time of I mod 60. Whoa, this girl has solved a lot of questions, man. God damn, good consistency. Wow, amazing, amazing level of dedication. Amazing. She's in which company right now? Whoa, just wow. The level of dedication this girl has. Okay, my internet sucks, but yeah. Yeah, many people like this approach. Okay, guys, I guess I need helping hand. I need to ask my better half about how should we go about this. She might be able to explain me properly. But yeah. Oh, okay. She got into JP Morgan and Chase 3 months ago. Web development intern. So don't tell me she did that all in her undergrad. Why isn't she targeting? Let me send her a connect request. Send without a note. It's okay. Okay, yeah, but JP Morgan Chase is a good place to start. No doubt about that. Cool. There should be a follow button somewhere here. Okay, no worries. Okay, guys, that I guess I need to go and see what I can do about this question. Talk to you later. Bye bye. See you in the next stream. Oops. And my camera died. I didn't even notice. Okay,